Hi everyone, welcome to HCD Robustness meeting. Today is June 5th, and we on our agenda we don't have any questions. There is no recent issues, but we can go to the dashboard and start triaging and looking into what we see. Maybe I was not fully accurate because at least I know that there is an issue. If you know that there is an issue, Huawei should know that there is an issue. And I'm not 100% sure that this is a real issue, so I asked for help. But it's pretty interesting one that I have never seen. So maybe we can look at that. But before we dive in, are there any questions from people in the room? Let me increase the size of the text so we can see better. Okay, if there are no questions, let's look at the one issue I found, or at least I filed during the week. It's pretty interesting one because I've never seen it, the case like this, and I've never even, I only reproduced it, or I didn't reproduce it. I have I have found it locally. So the only way to find it, there is no link, is to pick the report from the zip I uploaded, which is in pretty similar format to the ones that are on the CI. So if we quickly take a look, there's no issue with linearization. So all the requests, or at least we didn't find any issues with linearization. One interesting thing to point out is that this is not from the main branch, it's from development. So it includes a new type of request, which is compaction. I've been trying to get reviewed. If you're interested into helping getting etcd contract, etcd and Kubernetes contract in, this is pretty interesting and important issue, and it should help us with producing one of the correctness issues that we found before, because this adds a continuous compaction during robustness tests. But the problem is not about, or the report I found is not about compaction itself. That's why I don't think it's an issue with the code I've wrote, hopefully. But with the, it's an issue with the multi-operation transaction. Sorry for that. Let me turn my phone off. Yeah, multi-operation transaction. And let's look, what is the problem? So if, So if we look at those operations, this is, you can clearly, we can see that this is etcd traffic because they're get, puts, and they're multi-operation transactions. Delete, get, for example, this is a multi-operation transaction. It has delete, get, put. So we are in, so this is not used by Kubernetes, but it's implemented and supported by etcd. And etcd supports any combination of puts, deletes, and gets within one transaction. I think the limitation is, I think you cannot do it on the same key. And that's it. That's the only limitation. So you can do multiple operation at the same time on multiple keys. It's pretty useful thing if you have multi-object transaction, which Kubernetes doesn't have. So that's why it doesn't use this. But still, it would be good to understand why this happened. Yeah, but so this is how I decided to format those transactions in the robustness visualization. So you would get puts, get, which will give you okay for successful puts, and then results from the get, like here, 56 and like 49. And but going back to the issue, so you will not see the issue in the linearization because the issue is with watch. I pasted the logs from it, and it happens to mention that the variable is broken, which means the if you go into robustness test documentation or etcd documentation, I just like it's quicker for me to jump through this. One of the guarantees that etcd provides is reliable. So reliable means in a sequence of events, a sequence of events will never drop a subsequence. So if there is A and C, then it must, and A and C were delivered, the B should be delivered. And in this case, like it is missing. So how we can check that? First, we can take the report as discussed in the robustness documentation. Let me see. I opened it somewhere. Okay. Here in the robustness documentation, how to reevaluate existing report. You can like follow this, but I'm doing exactly this. I have my etcd fork, and then or local, not a fork, local version. I can go into test data directory, and I can copy the report. There is some other report. I don't want to see it. I just want this report. I can copy it. But of course, it doesn't work. How to do that? Let me open files, and maybe this will work. Yeah, it supports it. So now there is a file, and there is a special command, make test robustness reports. And hopefully we'll get something. I expect it might fail because we are not on the exact PR. Yes, it panicked because we need to be on this PR, if I'm not wrong. So I have a local uh, uh, so I have already like my remote locally. So if you would need to download or pull the add a remote to your local repo and fetch from my remote or my etcd fork on GitHub to get the code, like same as PR. So yeah, we have linearization failure. Oh, but this is interesting. This says linearization failed. So maybe I was wrong. Maybe there is a linearization error. That's a doozy. 15, 16, it lost compaction request or didn't go through compaction, and it didn't find any linearization that includes this compaction. That's weird. So maybe it was an issue. So FOA to FOA, maybe it was my mistake. So let me clarify that. that I yeah. So maybe before I can confirm, but this is I think I made it didn't something went wrong, at least in this case. Yeah, so one problem is every time we make a change, like extend the model, like in the PR, we need to extend the model to handle new type of request. There is an increased possibility of this model having a bug. And always when you run robustness test and you get a failure, it's a question, is it a problem with etcd or the model? And you need to double and triple check before, like you know, maybe not to file an issue, but before you make a claim that this is a really a correctness issue on etcd side, you need to double and triple check that it didn't work. In this case, I don't see anything, like I will not double check it, but I don't see anything wrong. This compaction should be part of linearization. I don't know why it is not. Um, Possibly because the code changed underneath. But I will not spend more time on it. I didn't provide the commit hash, so it's hard to even ask someone to follow through. Okay, so let me look up. Let us look for Etsy robustness dashboard, but there is one great news. Thanks to, I think, Xuan work, we now have dedicated tab for robustness. Sorry if I think I remember immediately after the last meeting we got a PR to add the dedicated robustness dashboard for Pro. So I think we can start including it here. Yeah. So maybe let's call this Pro. No, this is GitHub. Yes. Robustness for GitHub Actions, and this would be robustness Pro. Yeah. And we can add the feature template. I hope that within a month or two, we will fully migrate robustness to Pro. And the reason is clear. Like if you look at this looks bad. But if you look at the Pro use looks amazing. Like it's green. And it's clear that all the issues with on GitHub mean there is an issue with GitHub because the same code runs on both repositories. So all the flakes come from GitHub Actions, maybe some timings, maybe jobs being killed, maybe not enough memory, maybe not the same performance, but it gets the issue. For example, here, this sign means if you go that there were no workers for the robustness tests. So apparently ARM was unavailable for some time on GitHub Actions. But we still need ARM on the Pro side. So maybe as the Pro is most stable, maybe we can look at the failures from Pro because they have higher chance to being a real issue instead of a flake. But it's still useful to look at flakes to and then identify why they happened and maybe how we can reduce them. So we have within how many days? Like 2 weeks, something like 2 weeks. 22. Yeah, from 2 weeks period we have 4 failures, which is both good and bad. It's good uh, because every time we run every or behind every of those runs hides like hundreds of executions, like a lot of executions. So it means that the flakiness, like per test flakiness, is very very low, but still it's bad because it's high enough that we see it and we need to look into it. So spend some time. Uh, so let's start from this. I think we need to have some naming scheme, or we could use numbers with links. So this one failure, and the logs are somewhat surprised. Sure. No, this is a setup. So this is the full log from the failure. So yeah, on Pro it's very nice UI that you can dive in. And we can just jump to the bottom. We have a linearization failed. That's usually a bad sign, or a good sign, because it means either model is wrong or etcd is wrong. So how do we find the report? It's a good question because I haven't yet done downloading the reports from the Pro, but yeah, as you can see, you have artifacts and you have access to DCS bucket. In artifacts directory, you can find the results. That's it. Thank you, Shivan, for doing the work needed to get this. It's amazing that we can, like how good Pro is compared to previous setup. So we get the reports. What would be, okay, let me close this one. Maybe we can start from looking at linearization because linearization failed, so we can quickly jump to it and see. Okay. So this is the third type of issue that can happen. I thought I fixed those, but apparently not. So what happened here? Here's the one special case that I have a horrible hacking implemented. The special case because this is the end of the linearization. So for all those requests, everything worked, but it failed on the last couple of requests. And the reason is because we handle those last requests in very special way. The reason is that what is the reason? How to explain it quickly? The reason is that the linearization tool that we are using, called Porcupine, doesn't allow us to have a failed request. Let's say, if the problem is if there is a failed request, from client perspective, we don't know why it failed. It could, and there are a couple of critical moments in request processing that can impact, that can really determine what is the effect of the request. If we fail a request when at the beginning when it's sent, we are pretty sure that it will. We can assume that it will have no side effects. And then when if the request sent when the server was responding, then we are it can be clear that like we just didn't get a response, but we could still get or the request could be persisted, but we will just not get the response. And everything between those 2 points is random. Like you don't know. Like request could fail before writing to disk, after writing to disk. It leader could fail and fail to write it to their wall, whatever. Like you so from client perspective, we assume that every we need to assume that every failed request could be persisted or could be not. So the both sides. So if you look at if you would read the etcd model is pretty like it's codified in etcd model. It is codified as two different implementations of the model. One it's called deterministic, and second one is called not deterministic. The main difference is one assumes that all the requests always succeed, so it only goes through happy path. I think it's like described if you read like here, and the other one extends the non-deterministic model extends the deterministic model to allow for imperfect client knowledge. So the knowledge, if client didn't get a response, it doesn't know what happened. Like, and it needs to handle all the cases. So what really happens is if the request failed, we take instead of having deterministic state, instead of having one state, assumes or has a list of all possible states, and every time there is a failure, it just multiplies all the states with another unknown. So the model becomes exponential. So every time, so if we start from the beginning with one state, like everything is known, we know where it is. The moment that we encounter a failed request, we need to double it and account for the request both if the request passed and request failed. And this is horrible. I mean, horrible from how complicated it can get and how to account for that. The other thing that we need to account when we have this failure of the request is that the porcupine doesn't allow us, or when the request fails, we not only know what was the result on etcd or if the request passed or not. So what was the impact on etcd? So, but we also don't know when the request, if it succeeded, or if the request changed etcd. We just don't know it. If it happened, but if it really changed, we don't know when. So this is the second problem. We don't know if it's changed and when it's changed. And from linearization point of view, when you don't know when the request finished, you need to assume it never finished and it finished in infinite time. Like you need to assume that the end result is like or maybe to explain it, when you have a request, let me again type the code. If you append if you want to account for a successful request, you just put input, which is request that happened, output, the response, when the request started, when the request finished. And it's clear, like it's simple, like you just record all the requests that happened. The problem happens when this request failed, and then you need to hack around the situation because or I thought I need to track around what is here. I recently changed this code and I don't remember how, which is not good. Okay, I feel something didn't go wrong. Didn't go. Oh no. Okay. Oh, okay. Yeah. I changed the code. It's a little different, and here we assume that we just passed the time that we got error, or there was a recent change that handles writes and reads differently. The difference is that if the read failed, we don't care. We don't care. Like if the read failed, read should not impact etcd. So even if it failed, it doesn't matter. What is important, if the write failed, we don't know if it changed etcd or not. So for read, what recently changed in the code is that for reads, I especially I just record the original time when we got the response, when we got the error. So this error could come from client, network, or etcd itself. So we don't know, but we record this. And if it's a read, we just keep it just because we have an error, and we don't care. Like we remove it from if it's not even included in serialization, so it can have like the time, like fake time, end time, because it's good enough. But for errors, or for writes, we will remove the original return time and set it to -1. And also we will create a separate stream of responses. The reason we set the time in -1, it's a special value. Maybe I should call it. It means like infinite. For in this case, we don't know. I just assume this is infinite, and we could write like if in int we could write an infinity in int or max int. But in this case, I just wrote use -1, and this -1 is later fixed to be a real value, and the real value is based, is fixed here. So when we finish recording all the requests and we try to extract the operations from the history, we then check all the failed requests if they are the failed request with unknown return time, and we set some max time plus some imaginary time, like we add a nanosecond or add a sec, whatever, we add just last observed time. Okay, and the last observed time is just like maximal time from correct times. So this is why the end of linearization gets tricky, and because we need to fake the response the last time, and it means I thought I solved the linearization of the last request, but unfortunately looks like I make a mistake. So this is this fact that etcd didn't linearize it correctly is mostly on bug in linearization code. I based it on the fact that I'm I know that if there is a request with unknown result, it means that we played and modified the end time usually, or if there is a error or unknown, we are guessing the timeline. We are re-guessing the timeline based on different types of data we got independently. And apparently I made the mistake, and somehow the minimal thing that would fix this situation would, if this request and this request were a little bit like this line would be a little bit further and longer, enough to cover any part of the tombstone, because apparently this request failed and this request failed, and then we assumed, oh, the request finished, let me put the tombstone, just to like tombstone to simplify the linearization. And apparently they failed after the tombstone request, because tombstone request has a 938 revision, which is later after some last requests. So this is a bug in robustness testing. Maybe let me use Shutter, or let me use, let me file an issue for this. Are there any questions to this investigation? Is there anything else I could clarify? Mm, mm, mm. Okay. Oh my god, it repeats. Um, oh yeah, of course it doesn't allow. Um, um, okay. Okay. So yeah, so in such situations, you can just file an issue and hope. I know this was not reported yet. I'm really surprised. Yeah, so there is still this kind of issue. Okay, we did one. We can look into other issues. Mm, okay. And here we have null pointer reference. Broken assumption, null pointer. Where is this null pointer? Validates. 34. Uh, so this is null pointer exception on a fatal. I didn't expect that. Or maybe I read it wrongly. Oh, okay. So this is a fatal that caused another panic, or caused a null pointer exception, because here is the stack trace from fatal, and here goes to go, like whatever, go exit. And here, when trying to forcefully stop cluster, we panicked. Okay, that's a small thing. Mm, and this fatals because mm, I don't know why the the page doesn't render correctly. During a kill to expect, so the expect already finished, and like I think it nilled the process, so process is already dead, but it got a kill, so it's a race apparently. uh, I don't know. We could fix this race, but it doesn't matter because the somehow it's still already like it makes investigation a little bit harder. But there's still like the issue of fatal is left. So if someone is interested into investigating why, if we can avoid null pointer exception to just have a clear fatal, feel free to look into that. I think the more important and interesting thing is find why there was a broken assumption. So I recently added a validation into the validation into or assumption checking into validation. Do not repeat myself. Which tries to check if there is any, if the files or report that is provided is makes sense. And one of the things that it checks is there an empty database at the beginning or at the end? Has the first request succeeded? And I also like to ask if the last request succeeded, because that's why I have tombstones, because they make it much easier to having those assumptions makes the validation much easier to write. So those are just assumptions that could be relaxed, but that would require complicate some other code. And yeah, so it would be good to understand why it happened. So, so this happened because failing. There was a failure of injecting a file point defrag before panic, and it failed because of timeout. I've been recently seeing more and more of those issues. So I think, if I remember correctly, if there is some code path that if a file point is injected incorrectly, will not be able to collect all the things. So that's why the panic is so or the fatal with assumptions. So this failed already. Like this test is already doomed since the injecting a fail point prevented to do a full round of robustness injection. So those errors are just like repeating what we checking all the other assumptions that are also useful to maybe log and double check. And the question is why etcd failed to crash on this. Um, if you read the logs, here are the logs from etcd. It's useful to look into which etcd we were injecting in file point 2 into server 0, and but we can see before, like during this time of trying to inject the error into the member 0, the member 2 was really vocal about some other things. Like there is also some logs from member 1 that was doing something. Mm, uh, but this can be, I think, summarized that I think the leader was not able to write to a follower because of some reason. I assume because it was down. So it would be good to find a first log where, or last log where member zero was still alive. It can take a lot of time, or you can jump. Okay, we can jump here. So here we can see the last logs that were written by member zero. Member zero is the member that, well, we injected the fail point, and we can see here triggering the fail points. We set it up and we triggered. Would be nice to see which member we tried to trigger it on. Unfortunately, I didn't thought it out. We should, maybe you should add it to logging. Um, what else? We set up the fail point, triggered it. The member started the fragmenting, or setting up the fail point means using the Go fail library. For everyone that doesn't know, etcd previous maintainers have developed a library to inject fail points into Go programs. It's pretty useful for simulating failures like this, and you can simply do, or it works by adding a comment like this into code. Then if you compile your binary, if you call Go fail enable and then compile your binary, it will then expose an additional, you can have it expose additional HTTP endpoint, and then you can curl it to have it do the fail point. I think it's not documented clearly, but the interesting fail points, like at least in the case, the most popular in robustness test, is the panic fail point, which should cause the program to panic. And I lost track. Yeah, and this is how it is, like, oh, stringified. The name of the fail point is the name of the fail point, so you can find it in the code. Here it is. This is the fail point, and you can find if you pass panic as command, it will panic. I'm thinking about adding exit because I think panic in Golang is handled different than panic. Like if you call OS exit, it will do different path than panic. Panic is much more nicer where it will crash than OS exit. So that recently came to my mind. But going back on topic, the process or the member zero started defragmenting. It did some work, and then it went to the panic that was set up. So we just going back. We first set up the fail point, which is we set up the Go file library, and then we are triggering, and triggering means if there is a fail point that requires us is in code path that is not normally called, we need to do some things to trigger it. And in case of defrag before copy fail point, we call defrag. So this is why at this exact or this is why I talked before that we are adding a handling of the fragmentation, but still here we see etcd defragmenting robustness test because we only currently in robustness we only defragment when we are injecting a fail point to defragment. That requires us to defragment. The goal, high level, is to do continuous defragmentation because this is what Kubernetes does and users do. So continuing here, we have injected the fail point, etcd shutting down, crashing, whatever. Here it reports that, oh, triggering failed. This is interesting. Or it is expected or not. Because trigger means making a HTTP request or making the compaction request. And if it's panic during handling compaction, then it means that it did what it's supposed to do, and this call is expected to fail. I don't remember why we repeat again that we are. Maybe I think there is a loop just tries to trigger it if it's unsure that it failed. At some point, it should report that member exited as expected, or yeah, server exited with status code 2 and waiting for and this here is a member. Oh, so here member didn't exit as expected. So this is not clear, at least even for me. Why? What is the time? Interesting would be to look at the time. Here is 23:50. And there's unfortunately a lot of logs. So we need to scour through them. And the server panic 22:50, and then it's on 23. So for one, so the timeout, there was a timeout. So we were not able to go fail code didn't exit, which is not good. Code for fail points is in fail point, and this is go fail, and it looks like this. So first we, this is not the latest code, I think. Let's go to main branch as this is what's on code. Okay, so this is, so we first, as long as there is etcd is running, we set up the fail point. If we didn't succeed setting the fail point, we will continue running, and if we succeeded, we will break, which should go as here. If there is a trigger, and as long as etcd is running, then we should continue triggering fail point. And then we wait for member to exit. So this loop somehow didn't exit. So the first time trigger didn't work, but this is like why trigger didn't. Now we need to go to compact trigger. Because we expect that if we crashed etcd, we should only get error reading from server end of file. But in this case, we got connection reset by peer. I know this. I don't know when this can happen. Okay. So this is the difference between injecting a panic and OS exit. Apparently, in this case, server lived for long enough to send a reset packet. Amazing. And the fix is also amazing. You just ignore it. Does it make sense? Is anyone still watching? Just to double check.
Yes, yes, we are here.
Okay, Henry, is it clear for you? Like, am I explaining it good?
Yeah, it's
No.
understandable. Yes.
Oh, sorry, I don't hear you.
Yeah, it's all good. Don't worry.
Okay, okay. Um, I know the code is horrible. Sorry for that. I don't know what's the best way to. This is an error wrapped within error, so I don't know, and then passed through gRPC. So I don't know what is the better way to check it. It's not the nicest one because like this is a error from like calling client, and this will give you an error from wrapped around error about the error about error, and at the end will be gRPC error, and underneath the gRPC error will be what maybe I don't know socket error or TCP connection error. I haven't had time to even investigate if this can be improved, but this seems like. But if someone is interested in figuring out how to better check errors, that's encouraged. I don't. At this point, I'm not sure if it's like easy or more readable just to checking that this is connection reset error. I mean, we could. It's always good to double check if someone did the same word before. Someone already thought about adding this using the same idea for proxy. I didn't write this code. Don't ask me. Or this is a package proxy. I don't think I wrote this function. And connection error messages, integration tests. I definitely also didn't wrote. Oh, maybe I wrote this. I refactored this, so I don't think I wrote this. Maybe. And this, yeah, I didn't wrote this. Previous maintainer wrote it. So more passive, like the better way maybe would be to use the same idea of checking suffix, but I don't know if I care enough about if the error is at the beginning or on the end. Technically at the end because this is reported by the lowest level. So if not has suffix, that would be better. Yeah, but I'm not claiming this is the best possible solution. I'm just claiming that someone else did not. I didn't find a better solution, at least for now. Maybe because if there is a double dot, it means that this is like joining. Usually, convention of joining an error between Golang using error f. So maybe just a connection reset by peer is used somewhere. Maybe if you look, you could find this original string in the Golang library or whatever where it comes from. But I don't think it's worth to look. So yeah, I would fix it like this. So this trigger also does this. So this is common. The better way to do that would be write a function. Connection error. And we can do this and return this, or let's do some logic. So if error is this or this, and true, and if this error is not nil and not a connection error, then we can return it. Just as for sake of Like for example, if this trigger returns different error than we expect, I just prefer to be really strict about what has happened. We could look into maybe other types of connection on network errors. This is silence connection errors. Interesting. Maybe we could consider like unifying the logic in full etcd code base in one place, and maybe then someone can find like one correct way to do that. But for now, let's make it work. I lost the comment message. No. Ignore connection error, reset error when triggering fail points. Because now point. Son of Git and robustness reset. Yeah, if someone wants to do some very ambitious code review, please. I'm just thinking one better way to do that, it would be to add a test that confirms that when someone what kind of errors we can expect when someone triggers a fail point, but this triggers a fail point that way. And the only problem is that you cannot guarantee what kind of error you will get, so you would just possibly you would have a quicker iteration on finding what kind of errors can be quicker iteration loop on what kind of errors can be returned by the client, but it will not make the code correct more correct. It's just the proper way to fix it would be to do broader investigation and then submit the results. So I think we can just skip it. So I created this. I can post it. So if you're interested in reviewing code and becoming a reviewer, one of the goals of the meeting is to grow the reviewers for robustness test. I would be happy to just have a dedicated robustness test owners or reviewers. So etcd project follows the Kubernetes owners like subdirectory. So there's a main owners, there are main reviewers that do a lot of review. It might be harder to get into those because you need to have maybe broader knowledge from the code base, but there is nothing wrong with specializing. And if you go to robustness, maybe you could join, if you focus on robustness, I don't know, adding PRs, reviewing robustness tests, maybe it would be quicker definitely to grow into robustness role for reviewers and be added here. And I think it would make code base more or community more healthy if instead of having people needing to know a full code base in single person needing to know all the code base to get any position in the community, you would pick the thing that you care the most, go into that, improve this area, and become an owner in this area so that we can better scale the community by having a more distributed knowledge. We are after the time, so I think that's all for today. Hope that was useful. Please let me know if you are interested in doing any other investigation, if you want to continue the investigation that we started on the remaining issues, all of those failures for me are worthy to look at. The problem is we don't have enough people and time. But if you're interested in learning, you can do the same investigation yourself. I'm happy to help and assist and guide you if you do. And with that, that's all from me. Thanks everyone for listening, and hope to see you in 2 weeks.
Thank you so much.
Thank you.
Goodbye.
Bye.
Thank you. Bye.